Previously, we learned how to get a rough shape of the distribution from a given mean and standard deviation using Chebyshev's rule, which can be applied for any dataset. Next, we will discuss the empirical rule that allows us to better visualize the data if we can only assume that it has a bell-shaped distribution. For normal, also known as bell-shaped distributions, the Chebyshev's estimate is too rough and can be improved. If the distribution of the data set is or can be assumed to be approximately normal or bell-shaped, we can apply the empirical rule, which states the following. Approximately 68% of observations are within one standard deviation. Approximately 95% of observations are within two standard deviations. And approximately 99.7% of observations are within three standard deviations. For example, when the mean is 50 and the standard deviation is 10, roughly 68% of observations are between 40 and 60. Roughly 95% of observations are between 30 and 70, and roughly 99.7% of observations are between 20 and 80. The significance of the empirical rule is that it enables us to determine the shape of the bell curve from the mean and standard deviation only. First, we're going to draw a horizontal axis and label the values that are 1, 2, 3 standard deviations away from the mean, including the mean. Since only 0.3% of the data are outside of 3 standard deviations, we can draw the tails that are basically on the x-axis outside of the 3 standard deviations away from the mean. 5% of the data are outside of 2 standard deviations, so we can continue drawing the tails towards the middle by increasing the slope by a notch. 32% of the data are outside of 1 standard deviation, so we continue drawing the tails towards the middle by increasing the slope by another notch. 68% of the data are within 1 standard deviation, so we connect the tails with the bell-shaped middle part. According to the empirical rule, we have the following distribution of data under the curve. The middle 68% are evenly split into two halves, 34% each. 27% of the data is between 1 and 2 standard deviations away, which means 13.5% in each half. The 5% of the data outside of the 2 standard deviations is mainly concentrated between 2 and 3 standard deviations, which means 2.5 in each tail. We can do the same for any mu and sigma. For example, when mu is 50 and sigma is 10, we get the following. In the president's age at inauguration dataset, the mean is approximately 55 and the standard deviation is approximately 6.5. We can compute how much of the data exactly are within 1, 2, and 3 standard deviations from the mean and validate the empirical rule. Remember, the empirical rule only applies when the data distribution can be assumed normal. So just based on the two numbers, we would draw the following scale and would imagine the following shape of the distribution, only assuming that the president's ages are normally distributed. If we superimpose the actual histogram, we will be able to see that we are not that far off. We discussed the empirical rule as the way to try visualizing the bell-shaped data from a numerical summary. The significance of the empirical rule is that it produces a very accurate shape of the histogram based off just two numbers, the mean and standard deviation.